this is Chris. I'm in the roasting lab. Come on in. Roasting! This is the Pre-1Z Probot Sample Roaster. It's an electric sample roaster. I hear a lot of gripes about this particular roaster. Mostly the gripes are about the lack of control over the heat source, the energy source, which is electric, provided by quartz elements. Those are the quartz elements that heat the drum, the Pre-1Z. So the gripe is mainly about control over the power source, over the energy source. And you do have this one dial. So this dial controls the burners, or rather the elements underneath the drum. Sets that. That's your on-off. And over here is your little choke for the airflow. Right now I have that set at 50-50 for idling. The gripe about control in the Pre-1Z is actually pretty lame, because whereas it takes a while to respond to the adjustment over the elements, the airflow is super efficient, and basically having the drum wide open to 50-50 to all the way closed creates a dramatic effect in the drum and to the roast. So whereas you lose control of your energy source, namely the elements, you gain even more control over your airflow. And that actually, knowing that, makes that really easy to create a really wonderful roast. I like the Pre-1Z because it's really safe and really consistent. Basically what I've done is found a sweet spot with my energy setting for the elements where I can get as much energy in the drum as possible without scorching the beans upon entry. But having that much energy at the beginning of the roast allows me to give and take with the airflow and really direct the roast, really fine-tune it. And it's super consistent from roast to roast, I've found. So I've been really pleased with it. And frankly, I've been surprised that more roaster manufacturers have not looked at electric roasters. The coffee I'm going to roast is the Guatemala San Diego Buena Vista, which is a really nice Guatemala. Lots of brilliant fruit and great body. So I don't have a bean probe on this roaster. I do have an environmental temperature probe, and that's what I base my drop temperature off of. And then all other adjustments are made based on time and bean development. So basically, this is the first one I'm going to do at this time, and I'm going to drop it just under 300 degrees environmental temperature, 300 degrees Fahrenheit, and once we get going and do a couple, I'll probably drop it closer to 275, 280. So here we go. When I load the roaster, I have the air all the way through, all the way open, so it's drawing air through the face of the drum all the way back. And so this helps create a more gentle environment within the drum, even though we have the energy cranked. Like I said, on this particular one, I have it right about just a little bit beyond 8 on the setting, which goes up to 10. And so upon charging the drum, I try to create as much energy in the drum initially, but then create a more gentle environment by having the air all the way open at that initial stage. And so I do this for about a minute and a half, right around where bottom out or turnaround is going to be. I'm not going to watch my environmental temperature too much, other than the dropping point when I charge the drum. I'm going to pay more attention to what's happening to the coffee, and I'm able to chart it along with the timer that I have set over here. So at 130, a minute and a half into the roast, I go 50-50 to kind of close off the airflow a little bit, trap a little bit more energy in the drum, but still it's pretty gentle. And we're going to have another 2 minutes at this setting before we close the drum off. Now, since the impeller for the airflow through the drum is housed in the body of the roaster, it's drawing the air through the drum down at the bottom of the back behind the burners. There's the compartment that's pulling the air down out of the roaster. So that's why the kind of the positioning of the airflow and how the air moves through the drum, how it interacts, definitely determines how it is that you're going to utilize air to roast this coffee. With a lot of Probot models, large production models, you have a blower mounted on the front of the roaster, top of the front. So what that blower is doing is pulling energy across the charge, across the beans. So you're using a greater airflow to draw more energy. When you reduce airflow in that machine, you'll actually slow down the amount of energy that goes over the coffee and slows down the roast. Whereas decreasing the amount of airflow in this roaster, because of where the air is positioned and how it interacts with this drum, by closing off the airflow, as I'm doing right now at 3.5 minutes, I'm closing it all the way. I'm trapping energy in the drum, and I'm not pulling cooler air through the face of the drum. So this is going to help promote my roast up to first crack. Here we are just before 6 minutes, and if you can see the color on that, it is really nice and yellow, getting in some orange already. So already at about 640, we're moved from the yellow into the orange. I'm going to take this through the first pop and drop it right around city level. All right, we're at 745, and we're starting to hear the pop. Really nice, loud, boisterous pop. I'm going to let this gain a little momentum. All right. So now that I feel confident that the coffee's got a nice, confident pop there, about 8:25, I put the drum back at 50-50. Let the coffee just kind of continue to pop. Don't want to rush it through the pop. Want really good development. And then about 30 seconds later, I'm going to open it all the way. For about 10 seconds, that's mostly to clear the chaff out, pull all the chaff out of the drum. All right, then I'm closing it all the way to push it up through the rest of the roast. All right, this is right about where I want it. Smelling the coffee, the nice bright scent. Open my airflow all the way. This is also going to pull air through the cooling tray. So here is my roasted coffee in the cooling tray. Thanks for roasting with me.